Shut up, Dylan. I'm also like...
Didn't Canada start it?
No? Wasn't it Ben Franklin?
No, it was Canada.
Was it?
Like 6 months.
Those damn Canadians. I'm American too, so I can say that. Yeah. So bear with me. I am like staring at a tiny version of that. So I'm going to try to like scroll through. This is available on our meetup page. So if you go to meetup.com right here, this is Python, and you go to this guy, you'll see there is a link right here. Is that a link? I can't even tell, it's so small. And that will take you to our Etherpad. So I found out that Mozilla is going to be like getting rid of their Etherpad, so it's like, let's host our own, which is sad, but whatever. Oh, remember when Google Wave was a thing? No?
That was so
Yeah,
long ago.
Did I just date myself? It's like, oh, did they have cars back then, Ferris? So we got a few things. We also have our Teespring right here, so we're actually going to be giving out a few of these stickers. But if you want another way to support your Python group, but you also want swag as a result, you can use that Teespring link right there, and we got all those things, and we also have these stickers that I'm going to give out. How many do I have left? I think I have a few left. I have 2 left, so I'll order some more. But and shirts, of course. I like the blue, but I think most people like a black shirt. Yeah. Welcome. Everybody had pizza? Who had the vegan pizza? Yeah? Out of 10, how was it?
It was 9.
9?
Solid 9.
Solid 9?
I'm gonna go 8.5.
8.5. Always one, isn't there? Sweet. We got other groups around town. We got Utah Python North. My father couldn't be here. He has a cold. He's the guy who heads up that one. PyLadies. Anybody from PyLadies? Hi. Hi, Isla. Do you want to talk about PyLadies?
PyLadies is the super awesome Python meetup that's oriented to women, but men are also welcome to most of the meetups. Usually, if it's women only for a meetup, it will say that explicitly on the meetup agenda. We've had some really great talks lately. The one last month was about NLP, and it was amazing.
Have you spoken at the PyLadies meetup yet, Isla?
Yeah.
Of course.
I did a talk on Docker.
So Isla was referring to her own talk as being one of those awesome talks too, but she's too modest to say so that's okay. Python at the Point, South Valley. Anybody from South Valley? Any of those peeps? Well, they have their meetup at Canopy. So if you enjoy driving on I-15 during rush hour southbound, that is a great meetup to go to. I'm just kidding. They're great. They're really good.
It's during lunch.
Oh, is it during lunch now?
It's during
See,
lunch.
this is how much I don't know. Girl Develop It. Anybody from Girl Develop It? No? Okay, well, Girl Develop It is more of a workshop-oriented meetup group in the Valley for women. Anybody can join. Anybody can be a workshop leader. They're great. If you do lead a workshop there, you have the option of getting paid or donating that what they would pay you right back toward any charitable anything you want. So check them out. We got the data engineering meetup. We don't need to talk about that. We have PyData SL. I'm just kidding. Hey Joe, you want to give a quick spiel?
Yeah, next Wednesday at Overstock? Is it? I think it is. Yeah, at Overstock, we're talking about feature extraction in PySpark. So,
Fun.
yeah, it would be.
So that's the only other meetup I've gone to in Salt Lake City. I kind of feel bad about that. Kind of. PyData SLC. I don't know why their link is so weird. They are another data meetup. They are less focused on all the hard work, and they just focus on like taking that hard work and like presenting it to the bosses. Meanwhile, the data engineers are stuffed in server rooms and have to actually funnel all the data into a form that they can actually work on.
Not biased, Ferris, are you?
Sorry?
You're not biased, are you?
I'm quite biased. Okay, don't get me wrong here. But I mean,
I got opinions.
I have opinions. I mean, how many data scientists have never done data engineering? That's right. I would have kicked you out if you'd raised your hand. Websites, SLCPy.com. Quentin, where are you?
What?
I found the server. Quentin was asking me if I had lost the server. I found it, so we are good. And that's right here, SLCPy.com. Please ignore the fact that it's saying our meetup is in September, because it's right now. We also have the Utah module, by the way, so if anybody wants to pip install Utah, you can do so. Planning on extending it so it'll tell you all the meetups around you, but for now it'll just tell you about the Salt Lake City ones, so that's kind of fun. Sponsors, Pythonistas like you, thank you. Pat yourself on the back. If you haven't had a chance to give a $5 donation or not feeling it this month, well, that's fine. I mean, because we have other sponsors like X Mission. Can I give the spiel? X Mission. They won't throttle your data for no reason. X Mission. They will give you more than 1 terabyte a month, but please don't abuse it. X Mission. They're not Xfinity. Okay. And the University of Utah for the venue. Yeah. So, new sponsors, always appreciated. If you feel like sponsoring us, just hit us up on
Meetup.
Oh, right. Thank you, Dylan. Meetup.com is now a sponsor of our group, which is kind of cool. Yeah. It may or may not be because Team was acquired by WeWork, and WeWork also owns Meetup, so therefore I now work at Meetup. But that's a thing. Sorry?
Don't forget me.
Oh, yes, and Tech Systems. Hello. Tech Systems has sponsored many of our Raspberry Pis. Kate's right there. She is your local, friendly, vegan, organic, locally produced recruiter. So if you're looking for a change and you don't feel like taking on the full-time job of like job hunting and you want something solid, there you go. Time to network. Talk to Kate over here. Or you can get in on this who's hiring and who's looking.
And I
Right.
do actually have a data engineer role right now. So.
Oh, nice. Yeah, and I think it paid, what was it, 750,000?
Yeah,
Right?
pretty much. I mean,
Yeah.
I think that's a little low, but.
But it's a negotiable.
Salaries are trending up right now, so we are seeing things going up.
Yeah, unemployment's at one of the lowest, especially in this sector. So don't get lowballed, especially on equity. Believe me, especially on equity. Believe me, especially on equity. Because when your company gets acquired, you'll find out just how lowballed you were. So, what I like to do, if you're a new member, raise your hand. Ah, sweet. I took a picture with my face. So, now you're going to, like half the people are not going to raise their hand. Because you're going to introduce yourself. So, what? You're going to introduce yourself, and I have to think of something on the spot. So, it's November, so you're going to give your name, your occupation, and your favorite Thanksgiving side. It can't be turkey, okay? Unless it's tofurkey. If you're like vegan or something, then... Oh, actually, if you're vegan and you like tofurkey, I don't know what's wrong with you, because tofurkey's terrible.
No, it's great.
Turkey's pretty terrible itself. You know, it's on the bottom of the food chain. Like
I
very,
make a
very
very,
bottom.
very good tofurkey.
Okay.
Come on.
If it's a well-prepared tofurkey, but all the tofurkey I've had has been wanting. So I'll start. I'm Ferris. I'm the senior full-stack janitor at Team. I clean up other people's code. Now, I used to say back-end, but I learned Ember, so apparently I have to do the front-end cleanup now. So,
You can say full stack.
so I can say full stack. And I learned React, so I can do that stuff too. Ugh, just stick to Python, people. I'm telling you, like this event loop stuff and promises. And I like Python. We break our promises, okay? Unless you're using Python 3.7 and the async library, but whatever. And my favorite side is stuffing. I like a good Thanksgiving stuffing. So, who else is new? See, told you half the hands. And I took a picture with my face, so I already know who's not raising their hand? How about this gentleman? Be bold.
I'll do 2 at once. I'm on the Who's Hiring list as well. I'm Jerem Tollefson. I work at BioFire Diagnostics. I think we have like 220 job openings right now. So if you need a job. We're hiring software engineers 1 through 3, 1 through 4, director of software engineering positions, data analytics positions. There's just a crap ton of stuff. So if you want job bites from me, or if you're interested, you can look at their website, or I can send you a job bite directly. So,
Cool.
yeah.
Favorite Thanksgiving side?
Cream corn.
Cream corn. Interesting choice.
Yeah,
I like
my aunt
it.
makes a mean cream corn. Good, very good. So,
Is it a cream corn so good that it stops the Thanksgiving arguments?
yes.
That's what you need. You need a side that you just bust out
That's what it
when,
is.
like, right after the election, people start talking about politics. I got the cream corn right here. We're good to go.
Yep.
So, awesome.
Yeah, so I work in BioFire's service department actually right now, and I'm a full-time student, so I'll graduate this next year in the summer. Anyway, that's me.
Sounds good. Who else is new? This gentleman right here with the champion hoodie. Oh, or this one right here with the other hoodie. You're fine.
Hi, my name is Masato. I'm a student here in the School of Computing at the University of Utah. I'm a first-year PhD student in the scientific computing track. And I guess my favorite Thanksgiving side would be stuffed mushrooms with cream cheese.
Stuffed mushrooms, cream cheese. Nice. That is fancy. Who else is new? This gentleman with the hoodie that says champion on it.
I'm the hoodie guy. My name's Rob Maranowski. I'm new to Utah. I'm trying to start a small company. We're not really hiring yet, but we will be probably soon, so we'll talk about it if you want. That company's into blockchain and defense stuff. And in a previous life, I did a lot of Python and data science and Thanksgiving. I like stuffing, but there's a gluten-free kind that's made of cauliflower, so I like that one.
Oh, nice.
You should go to the blockchain meetup tomorrow night.
Okay.
Rob, where?
Lots of people that you could potentially hire in the future.
Yeah. Where did you move in from?
What's that?
Where'd you move from?
It's been difficult. Most recently, New Orleans.
New Orleans. Nice.
Yeah.
Another refugee coming to Utah. It's amazing. Because usually we have California refugees, but I guess you're our first New Orleans refugee. So.
Back to Canada.
Who else is new? Oh, to Rob's left right here.
You talking to me?
Yes.
All right.
I'm mumbling.
Dylan.
I'm sorry.
I work with the Department of Veterans Affairs at the Enterprise Data Warehouse, and I also describe myself as a digital custodian of sorts because I always get roped into all sorts of things that I would have never done myself, and expected to magic it all up. So, yeah. I like learning new things, so that's why I'm here. And my favorite side is probably just my mother-in-law's rolls, man. She can make these rolls that just sink me. I'm just like, just walk out with a bundle of those and forget everything else.
There you go. That's
just
a good
like go
side.
lay in them and eat them until I fall asleep in them.
That's what Thanksgiving about. Gluttony. Who else? Way in the back.
Hi, my name is James Longstaff, and I am actually, I don't really currently have a really relevant job in Python, but I am a recent graduate in applied and computational math, and looking for a position, and I really like mathematically modeling and stuff like that, and my favorite side would probably have to be stuffing from inside the bird.
Yes. You are a connoisseur as well, I take it. Hey, how's it going?
Well, much like good documentation, I know more about the campus now, but I was lost for half an hour.
Ah. No. Well, have a seat. You're up first, I think, right?
I think so.
Yeah. Whew, it's not a no-show, guys. I don't have to stall anymore.
Well, you do, because app got broken on my laptop, so I brought a mini workstation.
Okay, we'll switch around. Dustin will be going first. Sorry. Who else is new? Let's keep it going. We got a nice flow here.
My name is Brady. I actually have a background in this. I'm learning Python right now, so.
Me too.
So I actually currently work at the U, and yeah, I just work on the few kiosks here, so.
Fun. Thanksgiving side.
Oh, candy yams.
Nice. Good choice. It's like sugar with sugar. Who else? This gentleman with the baseball cap.
Hi, I'm Manish. I'm a PhD student here at the U, and I'm doing my PhD in computer engineering. I just started working with machine learning and deep learning as part of my research.
Anywhere. Okay. As long as you have HDMI out.
As regards Thanksgiving, I haven't had a Thanksgiving meal ever. So I don't know what's...
You're in for a treat.
You have not had Thanksgiving yet? I bet you like everybody here is going to give you a recipe, like on the way out, right? Yeah. Well, if you hear something that you sound like that would be good, like candied yams, just go and get the recipe. See, we're open source here, even with our recipes. So, all right. Oh, you knew?
Yeah. My name is Juan Ricardo. I was working for Science for 10 years in automation with performance, and go back to school, finish predictive analytics using R, Python, SAS. So last summer I was Aeon in Chicago, so doing externship there. And right now I'm doing Kaggle and looking for opportunities.
Oh, sweet. What's your favorite Thanksgiving dish? Turkey? You can just go for turkey. That works. If you have turkey as a side, you have a good Thanksgiving. So, who else is new? This gentleman with the orange inlined hoodie thing.
So I'm Loic. So actually, I'm essentially waiting for authorization of employment right now. So I came from France about 3 months ago, and so I used to work a lot with Python, essentially software development, and I'm still working at home right now on some projects. I've never had Thanksgiving.
Sweet, you have to gather recipes too. All right, about this gentleman.
My name is Chris Lau, from Hong Kong. So I'm a grad student at the chemistry department, and my favorite Thanksgiving dish, I don't remember the name of it, but there's some like green beans in it, and there's some like cream and
green bean casserole.
Yes, casserole. Yeah, that's my favorite.
Nice. Nice. Who else is new? Way in the back.
My name is Rio. I'm a data scientist at Uda Health, healthcare technology startup. It's based in San Francisco, but they have a team in Salt Lake City as well. And mashed potatoes, probably my favorite side.
Sorry, I'm trying to coordinate two things at once. Who else is new? I think this last gentleman who's been giving me the evil eye for skipping him this whole time.
A few times. Anyways, I'm Jeremiah Dickey. I work at tech brands. They own like Simply Mac and Spin Mobile. I do data stuff, analytics most of the time. I'm mostly projects, so I just run into project management. It's kind of fun. Oh, best side, probably stuffing.
All right. Anybody else who's new?
Should I introduce myself?
Oh, you already did last time, didn't you?
Yeah, that was my second time here
This is
now.
the first time you're news. Okay.
Okay.
You're old here now.
No, Ferris introduces you as the speaker.
Yeah, I will introduce you as the speaker. Don't worry.
We even tell you what your favorite side dish is.
Yeah, apparently. And we'll talk about who's hiring real quick. Who's hiring? Team's hiring like everything. Please silence your phones, people. Come on.
Come silence your phone, please.
Yeah. Team's hiring everything from like marketing. They're hiring everything. If you have ever worked in a corporate environment and know how to use a computer, then you should apply at Team, because they have everything from marketing to accounting to sales to like all kinds of development. They have mobile, front end, back end, lots of Python. Unfortunately, lots of Java. I mean, fortunately. Team is the best. So is WeWork. Yes.
There are some good things about Java.
Some good things.
Like not using it.
Let's see. BioFire, we already heard about BioFire. Market Dial. Who put this in? Like people are putting stuff in, so.
We're an A/B testing software startup, and we focus mostly in the retail space. So if you're interested in data science roles or data engineering roles, talk to me.
All right. The U, who put the U in?
That was me. We're the Department of General Surgery. We do research starting from acquiring the data to all the way through statistics. I'm going to start just cleaning the data and building databases, so we're looking for somebody to build analytic files from the data that I do, basically, and do a little bit of statistics. You have to know SQL, and Python would be awesome because I do most of my stuff in Python and just pretend like it's in SQL. SQLAlchemy Tensorflow.
Literally my presentation.
There
you go.
So after listening closely to this presentation,
You're well qualified to apply.
You are qualified to work in surgery. See, we are at a university, I guess. So.
I saw something about lasers on the doors.
Yeah,
Yeah.
there's literal laser research
In this building.
And if I'm not mistaken, this is the same building where that Utah teapot was.
yeah,
it wasn't this building, but it was the same campus.
It is the same campus. I
But
think
maybe
that's
not this
the,
building.
It's further
Maryland.
But this is technically the Utah 3D Modeling Museum. Like it has 4 exhibits, but there you go. Let's see, blockchain and defense stuff company.
I think that's probably me.
Thank you, Dylan.
You said you're doing blockchain and defense stuff. Do you want a picture?
The name is Coleman Run Networks, but yeah, so just keep an eye on us, I guess.
Blockchain and defense.
How did you spell that?
Yeah, 2 words, Coleman and Run. But you got it.
Progression.
Yeah, so we're a credit repair company. We help people get negative items off their credit report so that they can achieve their dreams.
Nice.
Being covered with more debt.
Yeah. We do well when everyone else is doing terribly. We have our marketing team is hiring a data scientist. They've been growing a bit lately, and it's a lot of different things happening right now. It's a big push in the company to build up marketing analytics. So tons of projects, lots of fun things, involvement with partner companies, and in-house projects as well. So I'm not interested.
Very nice. Anybody else know of anybody else hiring in the Valley? Going once? Going twice? Okay, we're good. Who's looking? Dustin Webb. Boom. Stand up and introduce yourself.
I will do that at the beginning of my presentation.
Boom. Who else? There was one gentleman over here who was like, oh, this one.
I
Okay.
introduced myself though.
But you have to now market yourself. You can't sell yourself. That's illegal. But.
Okay.
Market services.
Yeah. So I did my undergrad in applied computational math, and I worked on some different projects like a little bit of NLP. I made a natural language processing Arabic data classifier with Professor. So, and I've worked on other projects like right now I'm working on some unsupervised learning projects, but yeah, I don't know, those are some of my skills. I'm looking for something that's entry level, just to get some more experience. But
Do you speak Arabic?
Yes, I do.
Oh, Atini Esmak. No.
It's me, James.
James, okay.
James Longstaff.
What was it? Longstaff?
Uh-huh.
That is like the whitest last name.
Yeah, I'm ethnically ambiguous, you know. I don't know. Okay, great.
It's a Mideast feast here, guys. Come on. All right, who else?
How to market myself? I'm working at Zions for 10 years in automation, how to use automation. So it's a tool that could be used for marketing. I could do A/B testing or conjoint analysis to generate new product leads, or what the customer will like from the products, or what change you make, and also A/B testing for changes into website or different features, like what you could make changes to, so customers, to attract customers and to click or buy.
All right.
So robotics process automation. So looking into linking, for instance, to adding connections has been kind of painful. So we do robotic automation. I could go and add maybe 50. My goal is 500, 5,000, maybe 5 million. So it's going to go and grab the data from the websites, go into the connections, and try to add that on there. So everything will be automatic.
So scaled data modeling, A/B testing, is that the elevator pitch?
Yeah, random forest, logistic regression, linear regression.
Nice. You have.
And also, I have participated in competitions in Kaggle.
Oh, nice.
So, yeah.
Can I put you down as Kaggle champion?
Not yet, but
I'm going to put it down. It's written now. Okay, so it's official.
No. Grandmasters or whatever.
Who else is looking? It's Q4.
Do I have to stand up?
You have to market yourself. You don't necessarily have to stand up.
Sounds good. Hi, I'm Ray.
Hi, Ray. How do you spell Ray?
R-A-Y.
Oh, obviously.
Like array without the AR.
I will pay you $10 to say your experience with ray tracing.
Actually, so I undergrad in math and master's in theoretical computer science. Looking for something where I can apply that.
All right. NASA's always looking. Just saying.
The federal government. I was so ready to work for federal government, and then it was like, that doesn't look. I'm sure that's not gonna last.
But if you end up with NASA, then you can get out of here.
Interstellar style.
All right. Anybody else who's looking? Go once, go twice. Okay. Well, community news. USU is having a hackathon. Check it out if you want to help mentor university students in any kind of programming. They're having a hackathon, so that's cool. Any world-breaking news or not breaking? Any websites go down? This is the juicy gossip section.
Is there a net neutrality thing going on?
The Supreme Court did refuse to hear one.
I think it was California.
Yeah, it was somebody was trying to bring California to court for setting up their own net neutrality laws, and from what I understand, the Supreme Court refused to hear it, or they just passed down. They said whatever judgment was there is fine. California can do that, but they didn't say anything that definitive. It's kind of a bit of nothing burger. So keep fighting the good fight is what I would say. All right.
Good job, everyone who voted yesterday.
Yeah, thank you for voting. Make sure to vote again when appointed voting time comes up. America. New topics, speakers, anybody else? Would anybody like to give a short talk on a novice thing in December? Now's your chance to think about a talk, develop your public speaking skills. I will note that Python tutorial applications will be ending, I think it's the 21st, anytime on Earth of this month. And I think the talks will be ending, they have a deadline, and I think those are the end of this year. So if you want a chance to speak at PyCon, you definitely should be doing something here. And if you're thinking of doing a workshop, I can help you set you up a workshop in Utah that you can get a bunch of get a bunch of Pythonistas to go to, and then
Don't guinea pigs,
yeah.
aren't they prey of pythons?
Yeah, guinea pigs are eaten by pythons. Thank you. So yeah, that's the thing. Any other community news? PyCon's coming. I'm going to write just PyCon is coming. Oh, they're probably going to have the early bird application for that. I'll be sure to announce it on our thing too. But you can save like a couple $100 just by doing the early bird, and then you also will make sure that you can get the dinner. If it is in Cleveland again, so they have a Rock and Roll Hall of Fame dinner, which is both an awesome networking event and an excuse to drink beer and look at the legends of drinking beer / rocking and rolling. So, a lot of fun. Yeah. And if you do have a speaker, or sorry, if you would like to speak for the next talk, either in December or January or March, let me know. February, has anybody been to the soiree? Who's been to the soiree? Soirees are a fun little fundraising / fundraising event. We have that. Typically, we'll just have it at Mellow Mushroom again, at our old haunt, and it's where we eat, drink, be merry, and have a bunch of raspberry pies to give out. You can drink everything from soda to root beer to beer. So it's a lot of fun. Lots of good pizza, lots of good people, and it's kind of it's our birthday celebration. We're coming up on what, 5 years now, so happy 5th birthday to us fairly soon. And yeah, so we're gonna take a quick 2-minute break while we get set up over here, and I'm gonna go drink some water. So.
Okay.
Ooh. Here you go.
Oh wait.
Do you use the lightning?
No, just plug this cable into
I'm the community coordinator for the Rose Code project, an open source science fiction franchise. It's a ton of fun. And yeah, so the reason I learned SQLAlchemy was kind of a little bit out of necessity. Like at the time, the only programming language that I knew was Python. When I got introduced to this project, and I was like, hey, I want to help out, like help make our content management system and like all of that stuff, because we wanted to make sure that it could be truly and fully open source and allow people to make pull requests and things like that. So it is still a work in progress, but learning SQLAlchemy has really helped me out with that. So there's nothing up on the screen yet. So SQLAlchemy is what's called an object relational mapper, but I don't think that's perfectly descriptive. I think a better way to describe it would be a direct abstraction layer. What it allows you to do is create Python objects that are classes of different things, such as a column or a row or a table or things like that. And then SQLAlchemy will translate that into the corresponding SQL calls to whatever database that you're using, whether that's SQLite, Postgres, MySQL, Oracle, MariaDB, like what have you. So it's pretty nice for a couple of reasons, because that way you don't have to rely on creating just exclusively Python objects to work with. You can have everything stored in an SQL server, which has kind of stood the test of time, even though it's only being challenged now by, you know, other non-relational database paradigms. So, but you also have all of the advantages there in that you don't have to have like terabytes long Python files that have all of your objects stored in them. And you get like memory persistence and data persistence and all that fun stuff. I don't have to explain the benefits and wonders of a database. So I'm kind of wondering like where I should jump in. I guess I kind of want to gauge the room. Like how many of you have ever administrated a database, whether it was for like a class project, work, job, something like that? Okay. Wow, I feel like I have something to learn from you guys. And how many of you like can write SQL queries and stuff like that manually? Oh wow, there's like more people that time than the first one. I guess I'm kind of the opposite of you because I'm much better at Python than SQL. Like I was introduced the other way around. So I guess we can kind of just dive into it. Let's get our terminal opened up. Okay. So the other thing, I sure can. Is that better?
Yeah.
Okay. So I'm in my Python virtual environment that I made for this, where I have SQLAlchemy. If you wanted to install it, it's pretty easy. You just do this, like everything else in Python. It's wonderful. I guess kind of where I want to take it from here is, you've done that? Sorry, what?
I said, except for when you break pip, and then I muttered something about like, pip tent ropes and stuff, and it was like, what do I do now?
Yeah, that's literally what happened on my laptop today, and I wasn't able to fix it, so. Oh, I should probably connect to Wi-Fi. I don't really use it from this angle very often. Is it the top one?
You can, or you guessed. Ah. And then you need to go to example.com. Or just do that.
You didn't read it.
I usually do, but for the sake of time. No, like literally there was, yeah, I know that it's not actually HTTPS because it's not secured. No, like literally one day I was like downloading the Little Caesars app because I was like, hey, I'm going to order a pizza online and then just drive over and pick it up. And then I spent half an hour reading the terms of service and I was like, nope, they sell my data to way too many people. I'm just going to drive up and pick it up at the store.
Wherein they took your credit card info and then...
Right, and at least then they have to be PCI compliant. So I would like to have everyone write this down because this is very well fleshed out documentation. If you go to docs.sqlalchemy.org, and I'm going to say it interchangeably between SQL and SQL, like I don't really care. But docs.sqlalchemy.org, and then the current release is 1.2.113. And we're kind of just going to follow along with it. I'm willing to answer questions, or like if anyone has any questions about like the finite parts of how it works. I've read some of the source code. And then let's go ahead and actually, I'm just going to put these two side by side. So like I said, SQLAlchemy, oh, whoops.
You're probably a Python 2.3 complex maybe?
Oh, yep. I didn't go into Python 3.
It looked like you were in Python 3, but your SQLAlchemy is grabbing your home version.
Oh.
It's grabbing a PI file from your current directory.
Oh, that's
do ls.
Let's actually just do this.
Yeah. I see what you did there.
Whoops. And here is our first lesson. Don't name your example the module that you're using.
Or at least don't add that to your
It was a stressful day. When apt breaks because of a C++ dependency, you just kind of lose track of everything. So now that I think today is just another one of those reminders that I'm human. So now we have SQLAlchemy. We can do all sorts of things with it. We can import its subclasses. There aren't a ton of built-in classes just using vanilla SQLAlchemy. With what I've been doing with the Rose Code project, there's actually a small wrapper for SQLAlchemy called Flask SQLAlchemy that provides additional classes that are a little bit easier to instance. But if you're just learning the generics, if you're not doing a Flask project or something like that, I thought I should just go with the vanilla version because some of you are data scientists who aren't building websites or content management systems. So this part here, where it has us creating an engine is essentially the underlying part of the code that translates the Python calls to the SQL calls. It has engines for a bunch of different things, and for this example, we're just going to be following along and creating an in-memory only SQLite. And yeah, so go ahead.
One thing I know about an engine creates a connection to your database.
It doesn't necessarily create the database.
It's create a connection to it?
It doesn't
create the database.
It doesn't create
right.
the database
but
necessarily.
It creates a connection to it, right? You don't want to open too many of them.
Correct. Correct me if I'm wrong, but if I close this Python interpreter, it would cull that database from memory, correct? If we're doing an SQLite only or memory database?
Right,
okay.
yeah. Yeah, the SQLite from memory database, yes.
It culls it when you close the interpreter. Yeah. Okay.
Yep.
Because garbage collection's good. Where are the C people at where you have to code your own garbage collection? Sorry, I'm learning C right now. It's fun, but it's also a pain.
Makes you appreciate string class, right?
Yes. Although it is kind of fun. Executables are a little different than interpreted. Gee, I wonder why. Anyway. But yes, Dylan is correct in that creating the engine isn't necessarily creating the database. You can put other things in there, you would put, instead of SQLite, : // you could put Postgre or whatever else, have it be, and then just provide your credentials that it can log in as the appropriate user and manage the database from there.
This is where OneNote, if you're using it as for data science, where you're accessing an existing database, you want to create this engine once and not multiple times.
Yes, and then just reopen.
And then reuse that engine instance throughout your application.
Another thing here, which might be relevant for the data science people here, I'm setting echo to true, which is where it just logs everything and it's going to print out a lot more. Because we're all beginners here. Or not, but whatever. So, yes. So the first time you will create the engine, and then after that you can use engine connect. So anyway, yeah, go ahead. What's your...
I was going to say, we'll just go back up there for a second.
Yeah.
It looked like it was saying that it doesn't create the database connection until you actually try and talk to the database. Not just on that object creation.
Correct.
Yes.
But I have lived through a lot, deep down, they're don't create too many engines.
Yeah, no. Don't create too many, but just as a particular to know when that actual
That's true.
connection gets created.
Yeah. Yep, what he said. It is correct. So here is kind of like where we get into the fun part of it here, which is where, again, I don't have to do this with the specific library that I'm using, but this is how it works, is you're going to import a couple of different classes and then organize your objects inside of those classes so SQLAlchemy understands how to translate those into your SQL calls, such as column or integer or string. If you look through the Rose Code source code, I don't ever have to import all of those things. I just import it basically the entire library all at once, and then everything else I just instance whenever I want to. So. Oh, whoops, we didn't create our base object. Thank you. Earlier today, I kept spelling this word as this, and I was like, why isn't that module found? It's because you spell it like this. In fact, one of my pull requests with Rose Code was literally just like changing the way something was spelled so I could spell it correctly, and then I switched it back in order to be spelled.
You misspelled it.
I just like misspelled it so consistently where I'm like, I know I'm not going to need to touch this ever again once I create it, so we're going to rename it, not worry about it, and then rename it back. I still Oh, come on.
You forgot the I in faculty.
Oh, gosh. I should learn to take my own advice. Yeah. Except Control V does something different in the command line.
Shift Control V.
That's true. So, yeah. So now we have our base. We're going to go ahead and create our base object now that we have this wonderfully spelled correctly object imported.
You can call it. The declarative base needs to be called. Your previous line just says base equals declarative base, which is a function. Yeah.
I see what you're saying. I was like, I'm about to call it. Except that's not true, because we are making an instance of base. I was reading this fantastic series of quotes from one of the inventors of Fortran and Perl and things like that. He says, syntactic sugar causes cancer of the semicolon. I think of that every time I have to type a colon or a semicolon. So this is all boring stuff I should have prepared ahead of time, but it's been a day. Did we not? Oh, crap. Okay, there we go. I need help. Give me all the help you can.
This is group using tabs on those spaces.
This is designed by committee.
Yeah.
Higher programming to the next level.
Who needs Git when you have a crowd? Oh, come on, that was sort of funny. Okay, so I'm going to talk a little bit about what we did here. So we are creating an object that's called ID that is an instance of column. And inside of column, we are declaring the data type of integer, and we are saying that this is the primary key, like this specific object. In SQL, like, those are normal things you're going to handle all the time. But that's how we would translate creating an SQL table into Python. And then it's just basically repeat until you don't need to. And just for the sake of time, we're going to also put... That's awesome.
Can you hit Control L real quick? Just clear it, so, or, yeah.
Okay. Well, this is still needs to be part of that object.
I know, so
Okay.
people can see the screen. But now we just
scroll-
erased
scroll
everything.
through a
So
little
scroll up a little bit. There we go.
Your cross change.
Yeah, I think you're also outside of the blotter.
Do I need to do Shift Enter?
No, you.
Because this.
Oh, were you trying to do?
I'm trying to define a function inside of this class.
Yeah.
Because if you call an instance of this class without a representation function, then it doesn't necessarily have to return anything. You get to define what you want it to return, essentially.
So clear your current line and go up.
Yeah, so just go up twice, so you can add the class and redeclare it. Oh, you're not using IPython.
Nope, I'm using the regular Python interpreter. Should I just download IPython real quick? Didn't we literally have a discussion about that last time?
Yes. Yes, we did. Naughty.
Forgive me, Father, I have sinned. Okay, let's take a poll. Should I download IPython right now? Raise your hands for okay.
Just paste it. Or Jupyter, right?
You can install it from the interpreter? What? I was just gonna do this like a dumb, like.
No, pip install.
It's a pip install?
Yeah.
Never install system Python anything.
That's the lib, as Ferris would say it.
Yes, correct.
Did everyone get my ADB joke last time?
Using Python root. You need to install like Python root.
I don't do this professionally, by the way. It's not like I've been sneaking through life. Like, yeah, I know how to code. Hire me.
Modules IPython 3, isn't it?
Yeah, I think it's got it. Okay. Like this?
Yeah. There you go.
Okay. Guys, I learned something today. You came here to learn from me, but I learned something. Okay.
Feels like a Python badge right there.
Okay, so we're just going to do some copy and paste real quick here.
Middle mouse, but you will also paste faster.
I might have turned that off. Actually, not on this computer, because I don't use Blender on this computer. So funny story, that's actually how I got into open source and distributed systems. Is I was
the engine. Engines.
That's too much typing.
Yep.
I saw this meme once that was like one of the O'Reilly books. It was a sloth on the front, and it's like copying and pasting from Stack Overflow to meet arbitrary deadlines that mean nothing. You know it's a good tutorial when you can copy it in front of people and they actually learn things. Wait, sorry, what about Cheetos?
He's talking about the sloths being like the guy on that World of Warcraft South Park episode when he gets a tip on him. Pretty good. Slices him. I don't know, man.
Sounds like it's been a day for you too.
Yeah. I've been up a long time.
Hold on,
Could not assemble any primary key.
So don't put any blank spaces in the class. So,
Like this?
or in there, but don't do like a blank new one.
Oh, okay.
Do you have your email?
Do you want to send me an email?
Yeah, I have it all.
I'm not sure if I've logged into email on this computer. Do you want to just plug in? I mean, I can just go on to the next thing. We don't necessarily have to represent anything.
It's your 15 minutes.
Okay.
That will actually compile right there. You'll just have an ID and a name.
Yeah.
Right, but without any like printing out.
It'll still print out the.
Oh, whoops.
No, it's because
it already exists.
You already have a table name named users.
Oh gosh. Okay. So it's already been created then.
Yep.
And it's in the memory, yeah.
You can change the table name to losers.
How do you spell your name? No, we're going to make you an instance of this class. And then in this one, because I'm new to IPython, as you all just witnessed, would I just go onto the new line and then define my function from there?
Yes.
Okay.
Yeah. Although defining classes and functions in IPython's like pulling teeth.
Quick, someone recommend Jupyter to fix it. That was an invisible parentheses until like a second ago.
Still can't answer the single. Does that user actually need to be loser in this case?
No.
No?
Because it's just a string.
Yeah.
You can put whatever you want in it.
It's just XML.
Repr is just called if you call the instance. As the Python magic, it just takes whatever string repr gives you and then puts it to this command line.
Oh, I see. Right.
There's typically a underscore. There's a underscore string and a underscore repr. Repr is supposed to be a representation that could recreate the object, whereas string is just whatever you want to output when it's called. When string is called by that object.
If you're using an IDE, I don't even make a class of itself, because when you like say you have a class with just or a Python file with just models in it, you can import the models file and then you do models dot and whatever the class is, and it'll auto-populate in like PyCharm. So you don't need the string at all.
Yeah.
If you're using a terminal, that would be not quite as good. Autocomplete's magic.
Okay, it's kind of hard to check my syntax from this angle, so can someone who's closer to the middle just...
You didn't do it.
Okay. We good?
Yep.
Okay. Then how do you exit this?
Just one more enter.
Okay. This declarative base already contains the class with the same class and module as main.
You need to
change
your
the class
losers or something.
Yeah, change the class to losers.
Yeah, I did.
No, the class,
oh,
not
the
the
class.
name.
I see.
Although I think it already, maybe it made it. You should be loser.
Yeah, singular.
Well, what if there's more than one loser?
Well, that's what each one represents in an ORM. Just one loser. There are too many losers, man.
Well, apparently existing. It's just that they already exist. I didn't invent them. Which of us is older?
Extend existing.
First time you define a class, it made the table. So
Yeah.
create a class with a different name and a different table name.
Yeah. Or this is why
We're already too deep in. We already downloaded one new interpreter. See, I was waiting for it. Like,
Let's run it on PyPy.
PyPy?
No, never mind.
I thought I was the jokester here.
Hold on. User dot under table. User dot under table.
Yeah.
That's called a dunder?
Yeah.
Yep.
Oh, because it's a double under.
Programmers are lazy.
All right. Ta-da! Here it is. Okay. So I guess kind of where I wanted to go from here and like really what's been useful for me, where is it? Is
one thing I want to mention for people who are looking at this and who like SQL but want to get it into Python, that engine class that he has, if you do engine.execute,
that is a command, yeah.
Execute takes a string that's just SQL. So if you want to take your SQL knowledge, connect to a database and get it into Python, you can just use this, create that engine, do engine.execute, and it handles the requesting and all of that, and then gives you back lists that are your rows. So then you can treat them in Python.
Well, what if I want to use the magicalness of SQLAlchemy's query engine?
Well, then you create.
Then you create all of your classes and columns and stuff. I promise it's better than I'm making it look right now. Like
you can use both in the hybrid environment, and the advantage you get to that is you can still use the models to create it. But let's say you're using the SQL Server and you want to pivot. Well, you can't necessarily pivot in SQLAlchemy, but you can build a query that pivots just like with raw SQL. Oh,
it's painful.
Well, there you go. Where's my case?
How much time do I have?
They're touring complete languages.
Okay, so the other thing that I wanted to talk about is migrations. No, it's yes, migrations. I thought you said decorations because the top result there was find handcrafted basses and guitars. I was like, no, it is migrations. So Alembic is essentially a migrations manager for SQL, or you can use it with SQLAlchemy. I'm not sure if it will work with other things. But for example, like as we're building our content management system, we are adding tables, we're adding rows and things like that. In order to use our database, we have to create migrations and say, these new tables need to be created, that we don't want to delete our old data, and so Alembic is the tool for you. I really appreciate it. Unfortunately, I don't have a ready-made example right now. But the other nice thing, or the other thing I'll mention is that like, include your migrations. I don't know if any of you are working on open source projects, but include your migrations in your repository, because if someone downloaded an older version of the project and wants to contribute upstream, they're going to need to do a migration before they can contribute upstream. So, yeah. Anyway, does anyone have any like general questions? Someone who spends a couple hours a day working with this, with not this exact library, and you can see my struggles.
So Dylan had mentioned that that if you throw SQL through the execute and you get back lists, is it memory efficient? Is it going to be pulling everything from the database that matches that query, or is it going to be paging from the database effectively?
No. It'll just pull back everything your query does. So if you want to, like in that particular case, so actually you in your terminal do engine.execute and then ut, yep, and then
string.
Yeah, so string quotes, select, yep, space star, space from, space losers. Lowercase.
I'll give you the entirety of it.
Yeah.
Was it losers or loser?
Plural.
And then close the close the quote. Close the quote.
You got a quote.
Oh, I
And
see.
the string, yeah.
It's like there's
And then-
parentheses. What do you want from me, Dylan?
Yeah, you got it. You got it.
Parentheses.
Was it? I think it was just loser.
Okay.
No,
the
we
object
never
exists,
made it.
but it hasn't been stored yet. So it's like once you commit, it's going to give you all sorts of errors. But
Okay, so yeah, I don't know why it's not creating the table, but that's what you do, and then it gives you back the lists. And I have a helper function that then converts it into pandas data frames.
it returns a generator, right? Because if you just
you're right. It returns a cursor to the
yeah.
Oh yeah.
That makes more sense. That
Yeah. That's
So
right.
there's actually two ways to go about it. If you want it to read in and then read it out, like with a function, you just like say result equals and then execute blah blah blah, and that will iterate through it while it's pulling it in. Which means if you insert while you're pulling it in, you'll get a problem with deadlock.
Yeah.
But if you have a huge data set, you'll need to do that. But if you instead want to put the whole thing in memory because it'll fit, you can actually put the whole thing into a list. And then it'll put the whole thing in memory, and then you can do stuff, and then you won't deadlock.
That's what I always do. I forget that it's a generator.
I always do that, except for the one data set I'm on now, which is 15 terabytes.
But then it works really well, is that you can actually set this up and use SQLAlchemy with this in something that would batch it and just load it into memory, the things you need.
Exactly.
Yeah, and it works really well. So
it
does have all this relational mapper and object creation, which is really useful if you're building a web app to have functions, because you add extra functions to your classes. So users might have a instantiate, and it needs to build out a bunch of different things in your web app. And so it's useful to have an object as opposed to just SQL, because that object can have all those pieces together. But if your main task is just accessing the database and getting the data out, you can use this just as a connection layer between your database and your Python.
Yep. So one last thing I wanted to touch on, which you guys were talking about a little bit, is about how you access the database and things like that. SQLAlchemy includes a session management engine where you can essentially like do commits or reversions, similar to Git in a way, if you're familiar with that. And we don't really have time to go into it because it's time to move on to TensorFlow from someone who's much more experienced than I am. But yes, this is just a really basic introduction to SQLAlchemy, and Dylan and Matt know a lot about it. So, does anyone have any other questions or anything else they'd like to throw out? I also agree wholeheartedly. It works great with web apps, especially if you're using like a library like Django or Flask, which are just web service gateway with Python instead of PHP.
Thank you, Brian.
Yeah.
And we'll transition as quickly as possible.
I feel like that's probably going to happen. Okay.
Oh, sorry.
I'm just shutting down. I meant to type as a joke like the whole RMRF /.
You forgot the sudo in front of that.
I'm not gonna want that.
I'm logged in as root. I live dangerously.
Let's see what technical errors I can have.
A whole new set.
Right? Okay. So yeah, I'm Dustin Webb, master's student here at the University of Utah studying robotics and deep learning, and I have started a company called AI Influx. I'm searching for small businesses, charities, those types of people that are interested in these technologies but don't know how to use them or if they can use them whatsoever, because this is a bridge that I can gap for sure. 20 years doing software engineering, web, desktop, and cloud. Worked in all kinds of verticals: telemarketing, finance, radio, web analytics, robotics, and deep learning. Done myriad languages. Again, master's student at the moment. I have teaching experience. I've taught artificial intelligence, machine learning, and deep learning here at the UM Computer Science Department. General software development is
is a service that I offer, but I'm also consulting in these more advanced areas, AI, machine learning, deep learning, and I'll touch on how those are related later in the talk. I can also teach people how to use these things, and that's what this is getting to right here. Andrew Ng's quoted recently saying that AI is the new electricity, right? And that's to say that when electricity was first around, you had to have a specialization in it. You couldn't just plug things together and know how it's going to work. You had to have someone help you, right? And that's what I'm here for. I want to help people get these technologies and use them. So here I'm going to jump directly into defining artificial intelligence, machine learning, and deep learning, and really trying to differentiate them. Artificial intelligence, there's a lot of confusion around these terms. Some people think they're the same thing. Some people recognize they're different. Some people don't even know they're related. I had a question recently wherein I told someone I consult for artificial intelligence. They said, how does that relate to machine learning? Oh, that's informative. Artificial intelligence generally includes any program that is trying to solve a problem at human level capabilities. It doesn't have to have learning in it at all. That said, this is a Venn diagram. All machine learning techniques are artificial intelligence techniques. They are the learning components. They are programs that you give data to, and they modify themselves in some way to understand or to learn what patterns are there, to put it simply. Deep learning is a subset of machine learning itself. That I can, if you want to argue about that, I'm happy to argue about that. There's definitely a position to argue about that, but I'm going to go ahead and say it's completely subsumed by machine learning. And it's really the parts of machine learning that learn patterns on top of learned patterns. So if you have a machine learner out there learning some pattern, you can now put another machine learning agent on top of that and have it learn from those patterns and not the original percepts or the data that you might be playing with as a data scientist. So again, machine learning is the learning components. Machine learning currently is split into three major areas: supervised learning, unsupervised learning, and reinforcement learning. And this holds true for deep learning as of the last 4 years as well. It took a little while for us to catch up in the reinforcement learning regime. Supervised learning is to say, I have data and I have the answers that I want to predict. I'm going to learn something that goes from the input to that answer. The answer is very important in this case, because in unsupervised learning, I have the data, but I don't have the answer. So now I'm just going to try and look at that data and find patterns in it. That's what I'm interested in at this point. Those patterns can be very useful for other tasks. Reinforcement learning is sort of a broader technique where the agent itself is constantly learning and learning through interaction with the environment. So there is some environment, there is an agent, it takes an action, and then it reads a percept from the environment and decides what to do from there. Along with the percept that it receives, it also receives some kind of reward signal. I'm really not going to delve any more into these. Happy to talk about them at any point. Deep learning is why I came to talk. My research has actually been in deep reinforcement learning, which is the hybrid of deep learning and reinforcement learning, but I'm going to focus on deep learning today. A lot of people say it's rebranded neural networks, and I'll argue with you every day on that point, but for the sake of brevity, I won't do that today. Networks, so deep learning is often considered, or at least the tool of choice for deep learning, are neural networks that have multiple hidden layers. And in a moment I'm going to describe what a hidden layer is, so that'll make more sense as well. This technique has been around for a long time, or the idea of neural networks have been around for a long time, since the inception of computer science, arguably. But we haven't been able to get them to work because of the lack of data and the lack of compute. Once we realize that the internet is collecting gobs of data, and then all of a sudden we have all kinds of compute that we want from GPUs from the gaming industry, put these things together, we get some really good performance in learning. The applications for machine learning and deep learning both are immense. They're everywhere. People ask me, what can you do with AI? And I sometimes struggle to answer the question just because of all the things you can do with it, right? The first place that deep learning really took off was in object recognition. In 2012, a team out of Toronto built a model and swept the computer vision research. They showed that the state-of-the-art computer vision research at the time was getting around 64% accuracy on predicting objects and images. And these guys came in and did 84%, right? No problem. It's used for face recognition, style transfer. You guys have seen Prisma, the app? It takes two images, one, say, Da Vinci Starry Night, one of yourself, and then give you rendered as Da Vinci Starry Night, right? That is a deep learning application. Again, my research has been in robotics with this stuff, learning how to control robots. This is touching back on why deep learning is succeeding right now. All of a sudden we find ourselves with a lot more data. Machine learning, classic machine learning techniques are still the way to go when you have small amounts of data. But deep learning techniques are the way to go if you have a lot of data. And you can actually bridge that divide by building a deep learning model with lots of data for some task that's related to yours. Say you want to do NLP, right? You want to classify emails as spam or not. Then you can build an NLP model to simply read sentences and predict the next word. Now, if you only have a couple hundred emails, you can't predict spam using deep learning. But you can do this one task, modify the model just a little bit, and then train it on the spam task, and it will actually work. Again, I want to reinforce that for deep learning, you need lots of data and lots of compute. So let's get to what these models look like. The earliest model is called a multi-layer perceptron. The first neural network was called a perceptron. Right? Multi-layer is really talking about how many of these hidden layers we have. This down here is just representing the input data. It doesn't change. It's your image, it's your text, it's whatever it is. And the top layer doesn't change. It is the final computation of the network itself. When the data is brought in, say you have an image, well, that's simply a list of numbers in the end. If you multiply that by a certain weight matrix, one generated at random, add another random list of numbers to it, and then apply what's called a nonlinearity, something like a cosine function if you think back to trigonometry, you will get an answer. It may be gibberish, and it will always be wrong the first time. The training procedures for these update these random numbers to be numbers that are useful for then generating the right answer in the end. Right? Deep learning models really are referring to models that have more than one of these hidden layers in them. These models come with a lot of parameters. If you know anything about machine learning, then you know that you are really seeking out the values for certain parameters in certain models. If you're using a linear model, then you're looking for the slope and the bias, right, the offset. We have our trainable parameters, again, back in this other slide, the weights and the biases, the W's and the B's here. But we also have a bunch of what are called hyperparameters. These are parameters that affect the architecture or, say, layout of your network. How many layers you have, how wide each of those layers are, right? So here we've got a bunch of layers. The width of them is varying per layer. The activation function, again, looking back at this slide, this nonlinear function can be different things. Cosine, I should touch on the classic or most used ones here in a moment. And then something called the learning rate. How quickly do you want the system to learn? The faster the system learns, the quicker you get to your answer, but the more likely it's not going to be a very good answer. I actually don't have a good example for this. Effectively, the higher the learning rate, the more it's just going to memorize. And the less memory it has available to it, the more it's going to forget other things you've already taught it. There's several types of models that are very classical. The convolutional neural network, this is the model that came in 2012 and swept the computer vision world. It works off of spatial relations. So really what they're doing is they're taking a small weight matrix that's not the size of the image itself, but just a portion, and then they're moving it along the image. And as they do that, they're getting a single number for each position that this small weight matrix appears. And the result here is a filter map. It's just another image. It's not one that we can understand by looking at it, but it is still just an image. You repeat that process with a different convolution, as they call it, or kernel, as they call it. Repeat that over this new filter map, and you get another filter map. Once you've done this to however your heart desires, this is part of the black magic of deep learning, then you take this volume of images So this image, that image, this image, so on and so forth. You make one grand list of numbers, and you go back to the first model that we looked at. You multiply that input by a set of weights, you apply a nonlinearity, you repeat that, and at the end, you get out a prediction that this is a bird, or it's a sunset, or a dog, or whatever, right? Another popular model right now is called the long short-term memory. This is really useful for those of you that are working in time series data. Quants will definitely want to look at this. People looking at NLP will want to look at this. Its key feature is what they call the memory cell, which I've shown up here. You'll notice that I reference a lot of stuff from online. There's no reason to remake a lot of these. This one's just on Wikipedia. The memory cell itself is considered this central node. And let's see, how do I describe this thing? This is where the memory ultimately resides. This decides what information comes into the memory cell. This decides what information goes out. And then there's something that decides when the memory should forget. But this isn't anything that when you're actually applying this, that you have to think too heavily about. This is just the architecture. This is the mathematics behind it. Finally, a third one I want to point out is called generative adversarial networks. When I was in Montreal working with Yoshua Bengio, I watched Ian Goodfellow give a talk on this, the first talk ever, and he did not seem to think this was going to be a thing. As of last year, it is the most popular idea in deep learning. It effectively works as, if you're familiar with minimax algorithms in artificial intelligence, this is effectively the neural network version of that. What it's doing is it's saying, I'm going to take random noise, I'm going to push it through some neural network, and it's going to come up with a fake image. I'm going to have a set of real images. I'm going to take all of these images, and I'm going to push them through another network. And it has to decide which ones are real and which ones are fake. And then the training process itself, called adversarial training, updates the weights of this network and the weights of this network, making them battle against each other. The generator has to get better at making fake paintings if you were say dealing with art, and the discriminator has to get better at recognizing an authentic Van Gogh versus someone's fake Van Gogh. Right?
I got a question on that.
Please.
Do multiple iterations lead to better results, or do you get most of the bang for doing it just a single time?
That's a great question. When you're training these things, you're going to have a data set. When you pass all of that data set through the training process once, we call it an epoch. You will, on all of these, have to go through multiple epochs, usually hundreds, if not thousands. The state-of-the-art stuff that I work with can play Atari in 30 minutes. The first model in that area took 30 days for one game. Full run, full compute on a full GPU, 2,000 cores, right? Now you can do that on an 8-core CPU in 30 minutes. Nonetheless, it's still taking 1,000 epochs, or 1,000 iterations, right? So you will always find that you have to go multiple epochs. These beasts are rather difficult to work with. Oh, they're all difficult to work with when it comes right down to it. And that's another reason I'm here, is to help people understand how to work with these things. This one is particularly sensitive. Any of the hyperparameters, as I discussed before, if any of these are out of whack, these will not train. You will get terrible performance, right? And I'll be talking about training a little bit more here in a minute. Yeah?
Can you change the training data in each epoch? Like, for each epoch, does the training data change, or does it stay the same?
So there's a form of it can be either, to answer that succinctly, right? In the case where it changes, it's called online training. Where it doesn't train, then you have a batch of data, and it changes in as much as you shuffle the order of the samples, but the samples themselves are always the same set, right? So if you have an ordered metric, or if you have an ordering metric, you can apply to that. Then you apply to any shuffling, you'll always get the same data back out, right? A lot of deep reinforcement learning stuff is online, and so every time the robot runs through the room, it gets a wholly different set of data. And sometimes we memorize a lot of that data, sometimes we don't, because there's different techniques there. So, did I answer your question? Okay. So going back to the activation function, so I put it back up here again, the main equation that governs these things. The weight matrix times x plus the bias. Run that through a nonlinearity, you get your what we call activations. The classic nonlinear area was called a sigmoid. It looks like an S. At the very far left of the Cartesian plane, it's it gives you a 0, or effectively a 0. It never reaches 0 technically. On the far right side of the plane, it gives you 1, or as close to 1 as it'll ever achieve, since it doesn't actually achieve 1. I'll avoid the history of these things, even though I really want to dig into them. Tanh is a sigmoid, but it's been expanded in height and shifted down. There are some mathematical benefits to doing this, but it's effectively the same function for all intents and purposes. In fact, there is a deterministic function you can use to map between them. So you can argue they are the same function with, say, the right multiplication or whatever. The state of the art is actually called ReLU. Everything on the left half side of the Cartesian plane, if this is 0 on your x-axis, is going to be 0. And everything on the right side is just going to be whatever went in. So it's the maximum of 0 or x. So you'll never get a negative number out of this thing, right? These were discovered, I want to say, late aughts, and have just kind of killed it in performance. So they're de facto standard. There's a lot of theories to why they work. There's a lot of theories to why they don't work. And if we were to dig into training and the mathematics behind it, it has everything to do with the fact that this part right here is straight. So, getting to training. In order to train, you have to have an objective. You have to have something that measures loss. You have to have a reason for being, in effect, right? This measures your performance on a task. So if I'm wanting to classify pictures as to whether or not they have a dog in them or not, then it's simply going to be a binary classification. It's going to be yes or no. And I may use something called mean squared error, which is really just going to look like this bowl. If I were to take all the possible images and put them through this thing, I'm going to get this back out somehow, right? Another common one is called cross entropy, and then KL divergence is often used but not by itself. For instance, GANs are fueled on, or the generative adversarial networks, the last one we were talking about, are fueled off of the KL divergence more than anything else. This is a really pretty loss function right here, because ultimately, if you think about it, what we're trying to do is get to the lowest point on this surface. We don't know what this surface looks like, because the reality is that there's one dimension for every pixel in our image if we're doing images, right? In this case, this image only has 2 pixels, right? Not very useful. But when we're dealing with bigger images, we can't visualize this. So we drop down to 2 and 3 dimensions, or actually just 2 dimensions, so we can visualize these things. You can think in analogy that the objective is to drop a ball on this surface somewhere and just watch it roll to the bottom. Give it some time and it'll settle at the pinnacle, or the valley of this thing, right? But each task has its own surface. Some of them are a little more complicated. In this case, if you drop the ball, say over here, you're probably going to end up in this valley, and the error here is associated with this point is much higher than the error associated with this point. So you really want to end up here. But we don't know where to start in this field. That's another point, another piece of the black magic in deep learning. That said, this is still a really pretty surface. Sometimes they get like this, where you can end up on one side of an entire ridge and never even realize there is a better area to be playing in. Right? And there are techniques for dealing with this. Gradient descent is what I was just talking about, the analogy of rolling the ball down a hill. So if we imagine that surface, imagine the first surface where it was just a bowl. That's all that is being represented by this set of curves here. The smaller the circle, the lower the error. There are several different approaches to gradient descent. One of them is called batch gradient descent. If you take all of your data, run it through the learner or through the model, calculate the error, take the average, and then update the weights, you get batch gradient descent. If instead you take one sample, you put it through your model, calculate the error, and then update the weights, you get stochastic gradient descent. You'll see it kind of walks kind of crazy. But it's theoretically guaranteed to work. It just might take a little longer. In deep learning, we generally use mini batch gradient descent, which is to say we will take a few dozen samples, run them through the model, calculate the error, and then update the weights based on that. And you'll notice it still has a bit of a crazy walk, but it's not as bad as stochastic gradient descent. It's also guaranteed to converge. So really your best bet is to find the mini batch size that will fit into your GPU's memory and use that. The bigger it is, the faster you will get there. The training process for these models is pretty straightforward. You got to define your model. Am I going to use a CNN? Am I going to use an LSTM? Or am I going to use a GAN? And you set up the hyperparameters. They all have their own hyperparameters, and the number of layers. Yeah, I like that one a lot. And I kind of started talking slow because I wanted people to read it. You set up the hyperparameters for the model. You define the loss function. Each task has an appropriate loss function. Sometimes you have to make up your own loss function for your task, and sometimes you have to modify your loss function based on previous experiments you ran where you saw something didn't work, understand why it didn't work, add a term to the loss function, and go again. You then have to create training, testing, and validation sets. This is a little weird for your classic machine learners in the room. They're used to having just two of these, a training and a testing set. I'm going to train a bunch of models, and I'm going to test the one that works the best, and I'm going to call that the winner. In deep learning, we need a training and validation set because we will apply the optimizer to the training set, and then we will apply the loss function to the validation set because in training these things, we want to monitor them. But we don't want to monitor them on their performance on the training set. We actually have techniques for observing how the validation error changes with relation to the training error to know whether or not the model is training well. You iterate on steps 5 and 6, go back to the question that was asked earlier, until you get the performance that you desire or you see that it's no longer learning, which really is just represented by the error not getting any better. Right? It's not improving. I'm really not joking when I say that your first 1,000 models will fail. Right? You're going to go through a lot of iterations with these things, which is why I like this comic so much. It just seems very apropos here. To give you an example of these error curves, in this case, the green one is the test error. Sorry, the fonts are very small. I snagged somebody else's. And the blue is what they're calling the train error. This is their validation set, right? And what we see is that they're both trending effectively the same. This model is doing really well. It is training. The longer they let it go, the better it will get to some asymptote. It'll stop at some point, but you can often let them go longer than you ever want to.
Did you say that? Did you have that flipped? Would that be flipped, that the test here would be their validation set and the train here is their actual training set? Because your validation would probably be higher.
Yes.
Yeah, okay.
Yeah, yes, you're absolutely right. Okay. This would be their validation set, this would be their training set. And what's happening is it's memorizing the training set, but what we see by the fact that the validation set is training in the same way is it's not memorizing it to a detrimental level for the model. It can still see novel examples and do them correctly. That's not what's happening over here. In this case, the validation set, the spacing between the validation set and the training set is increasing, which is to say that it's learning to memorize the training set, and each time, with every epoch that it trains, it is less and less capable of seeing novel examples and getting them correct.
Is that the idea of overfitting?
That is exactly the idea of overfitting, yeah. I thought I put that on the slide. Thanks for pointing that out. Okay, so let's actually jump into TensorFlow at this point. And to what you said, I'm actually about half done. So I'm going a little faster than I intended. TensorFlow was developed by the Google Brain team. That's where Ian Goodfellow is now working, for anybody who's familiar with the history of deep learning. He was one of the founders of Theano, however, and TensorFlow is an answer to Theano and Torch. Theano was an open source library coming out of the University of Montreal, and Torch is an open source library that came originally out of New York University. This one by Yoshua Bengio and this one by Jan LeCun, for those people familiar with the area. They were doing it because there wasn't an answer to this problem, making it easy for non-computer scientists to train these models. Once Google jumped into the arena with TensorFlow and they got it working well enough, Theano actually dumped out. It's at end of life, and they're not doing that anymore. And it's because they got the answer they wanted. They got someone doing that part of the work for them. Torch is still going strong, but that's because the professor here went to Facebook And now he runs the Facebook AI Research Lab, and they've adapted this from what was originally Lua to all kinds of languages now, including Python. So that's definitely an option. PyTorch is the name of the library for that one. I don't use it, so I can't speak intelligently about it right now. But I can answer questions about the theory easily enough. It's a little bit of a misnomer that it's a deep learning library because it does support all classical machine learning methods. In fact, it will work. It will do any scientific data that you want. It's a very capable library when it comes down to it. Why use it? Well, it's a Python API. We're all Pythonists, right? It's popular. I went and found several different reviews on this with respect to popularity, and it consistently beats out the others. It is not the fastest. It is by no means the fastest. There are things like one called MX, which isn't even on this chart, that is written in C and C++. And so if you want speed, you can get it there. However, TensorFlow, while you write your part in Python, it effectively does its part in C. So it's getting increasingly faster all the time, and MX will be not as competitive because C and C++ are just kind of a pain in the butt to deal with. I'm sure a lot of you agree anyway. That's to say this is easy to use compared to MX and things like Caffe. Caffe is a very popular one. It came out of Berkeley also in C and C++. And then it's automatically supported on the Google Cloud platform. So if you happen to use GCP, it's there, available, ready for you to use.
So I heard about Keras being more of not its own framework, but just kind of a wrapper for TensorFlow or Piano or whatever underlying part. So can you talk about why it's listed as kind of its own?
Yeah. Where did that go? Well, I was coming to that one point, but we can jump to it right now. Keras was originally a library, Python library, that was written to obfuscate which library you were using, either TensorFlow or Piano. And then about a year and a half ago, they decided to make it an API, in which case, and then TensorFlow implemented that API. So you can go download Keras as a self-contained package and use it, and you can tell it to use TensorFlow or Piano. Or when you install TensorFlow, you automatically get that API available to you. It's available through tf.keras. So if you want to use it, you say tf.keras. And a lot of the TensorFlow built-in functionality is actually mapped into it, and vice versa. They're heavily integrated at this point. So so I'll be talking about that towards the end of this after I put you through a whole bunch of paint. Now that I think about it.
So just a quick question. You mentioned that it's natively supported on the Google Cloud platform. If you have like self-hosted hardware or a private cloud or something like that, how do you typically implement it that way?
You just pip install TensorFlow,
Okay.
or pip install TensorFlow -GPU if you want to use GPUs. That one's very important, and you do want to use GPUs.
Right.
So you pip install TensorFlow -GPU.
Gotcha.
You do have to have a GPU in your machine that's supported, and you'll have to check the documentation to see what's supported, because that's
The biggest pain
complicated.
point dealing with hardware is GPU drivers, honestly. Like everything else is pretty easy. GPU drivers.
I highly recommend just using an AMI, either AWS or the deep learning AMI or GCP. It comes out of the box. Rolling your own, do it at your own peril.
Yeah, it's great for development, which is what I do. But yeah, if you're trying to do this for scale or anything like that, get something that's solved already.
I was going to mention Docker as well. Docker has pre-made containers for these.
Yeah, in fact, if you just extend Anaconda, you get everything under the sun you could ever want for PyData, including TensorFlow and all the fun tools, pandas, whatever else, and you're ready to go in one image. Yeah. In fact, I've only been using Docker fairly recently, but I'm loving it. So these are the major concepts that I want to go through in quick succession. I'm not going to read them out because I'll be going through them individually. The namesake, tensors. What is a tensor? A tensor is just a list of numbers. Your classic scalar, what we all learned in elementary math, it's a number, right? And then at one point we get into linear algebra, probably around high school or college for some of us, and that's just a list of numbers. We also got introduced to matrices there, right? And these two things came together to solve multiple linear equations. So we learned how to solve a linear equation, and then they said, well, just kidding, we want to do something harder, and they said, let's solve two linear equations at the same time. And now we're like, oh, forget that, let's solve a million of them at the same time. Right? However, when you work with images, they have three dimensions, right? They have R, G, and B. Well, that adds another dimension to this list of numbers, and that's what is called a tensor. So a tensor is just an abstraction of the generic idea of a number, right? Any list of numbers that has more than 3 dimensions in it, or that has 3 or more dimensions in it, is just referred to as a tensor. And that's where the idea for the name comes from, because all of the data is handled as a tensor. You have a tensor, you operate on it, you get a tensor. You operate on it, you get a tensor. Repeat ad infinitum.
Geez, like there's a flow of them.
Right, right. And I'll touch on that later, actually, too. So maybe I did this in the wrong order because you guys are beating me to a lot of questions, but that's fantastic. I'm glad you're interacting. Variables, one of the most important concepts, because these are the things we're trying to optimize. This is where the memory for the system is located. This is where the knowledge for the system is ultimately located. They're generally the weights and biases I was talking about earlier. You can simply say, TensorFlow, give me a variable. Call it that, and this is the value. As far as the learning rate goes, for those of you who know machine learning, that's a terrible value, so we'll reassign it to 0.1. So you can change variable values, right? In this case, I'm saying I want a set of weights. I'm going to call it weights, and I'm going to initialize it using a random normal distribution. It is better in general to call get variable, even if you don't have a weights variable, because it will make that weights variable. It will give it its default value. It will give it a name. And then every other time you call get variable, it gives you the same variable. If you don't, if you call tf.variable and say call it learning rate, and then you do it again, you're going to get a learning rate and a learning rate 1. There'll be different variables. And so when you're trying to work with those things, you're going to run into errors that you don't understand. Placeholders are very similar, but they don't actually have any data. This is just a way for you to tell TensorFlow, when you're going to do this computation, I'm going to give you data to do the computation on. With the variables, you gave it the data in advance. Here, you give it when you're ready to actually use the model. And the reasoning for that will become obvious in a little bit. They, again, represent the input data. They do not allocate memory. They cannot be modified as a result. There's nothing there to modify. Here, I'm creating a placeholder that just represents a float with 32 bits. Because I'm not using a shape as I'm doing in this, it means I can give it any tensor I want. It can be 1D, 2D, 3D, whatever, it will take it. Best practice, provide a shape. Because the moment that you do computations on a 3-dimensional tensor and you give it 4-dimensional data, it's just going to blow up on you, and the error is cryptic. When you're working with images in TensorFlow, this is really just a side note. This is generally what it looks like. I'm working with a list of unknown size of images that have 28 pixels by 28 pixels in 3 dimensions for RGB. Everything in TensorFlow is an operator, except variables and placeholders, which really are still just operators. Tensors go in, tensors go out. I guess I'm trying to coin the Tito idea. If anybody knows GIGO, garbage in, garbage out, right? The operator class is extendable, so you can add your own operators. I've done it on a number of times because it's very useful. For a while, TensorFlow didn't have its own cosine. I needed cosine, so I gave it cosine, right? And it was not hard to do. It was a class and a function, nothing more than that. All the mathematical operators you're going to want to work with are there now, except integration. You get gradients for free, but not integration. And then optimizers, which I'll talk about more in detail, but these are algorithms that figure out how to update the weights, mathematically speaking. Some examples include, I'm going to take some input and I'm going to apply cosine to it, or I'm going to take 2 inputs and I'm going to add them together, or maybe I have a function in terms of y called z, and I want to take the derivative of that, or the gradient of that, right? And then I get the gradients. This is what made Piano, and this is what made TensorFlow. This is the biggest pain in the butt to code. And it takes a lot of effort to code. It takes a lot of effort to validate. And when you're doing it with every model, you spend a lot of time doing this. Once Piano implemented this, nobody ever did it again. If they were thinking correctly, they didn't do it again. This here is an example of building an optimizer to optimize the model with. And down on the bottom is actually coming from Keras, to go back to what we were talking about before, this is a simplification. So when I said multiply the input by the weights, add the bias through the nonlinearity, all of that, this does it all for you, one line, right? It's so common, they just wrapped it up. So optimizers, we were talking about gradient descent before. There are different ways to do gradient descent. I won't get into any of the details here, but I'm happy to talk to you about them if you have any questions about how each of them work. The common ones, of course, gradient descent with momentum. So go back to the visualization of the ball on the hill, the ball's rolling down. In this fake physical world, when the ball hits the bottom of the world, it stops. But in our world, the ball hits the bottom of the hill, it keeps going because it has momentum. That's what they're modeling in this particular approach. That will allow, for instance, the ball to get over certain berms and move through a more complicated surface. Atom is the de facto standard now. Previously it was RMS prop, and for a minute Adagrad had 15 minutes. They were maybe more like 2 minutes in history. It's also extendable, so you can make your own optimizer. If you have a new idea for how to, a new mathematical idea for how to perform optimization, you can just extend the class and do it yourself. You can also, instead of just fitting, which is the classic technique, I have my optimizer, I'm going to say fit this data. I can get more granular. I can say give me the gradients and then sometime later apply the gradients. So what I'm demonstrating here is that I'm going to calculate the gradients for my loss function on whatever my learning variables are. And then I'm going to clip them. That's to say I'm supposed to move a certain direction, and by the math I'm supposed to move a certain direction at a certain length. But maybe I don't want to move that far because it often gets you in trouble. So I'm going to move in that direction, but I'm going to move not quite as far that direction. That's what this is doing here. And then I apply those gradients so that I don't end up running off the side of the world or something. So this gets to the part that for me was theoretically the hardest part of TensorFlow and Theano, and that's computational graphs. When you are doing all of this, you're not writing Python and having it run your operators at the moment you write them. You're writing a description. It's analogous to defining a class in Python. When you write out all of these operations, you're just writing the class. It's a very, very complicated class, but nonetheless, it doesn't have any resources. And operations are added to a default graph, so when you're first learning TensorFlow, you don't even know it's there until something goes wrong, and you have to figure out, oh yeah, there's this thing in the background. What is going on here, right? It can also deal with multiple graphs, which I'm not going to really discuss whatsoever, but that is an option. There's some benefits to doing that. You can get the default graph if you ever need it. That usually happens when you're working with multiple graphs. You can always reset your graph if you've started to add some things to it and you decide you don't like them, say you're working in IPython or Jupyter, then you can say reset the default graph, and all of the contents of that graph will be wiped out and you can start over. Yeah, let's leave that there. The flip side of graphs, or classes, class definitions, are the instances, right? In Python they call them sessions. So this is analogous to a class instance in Python. I have defined my graph. Now I'm going to run my graph. It actually allocates resources. It allocates memory. It picks what CPU is going to be used or what GPU is going to be used. It does all the manual work of moving data from disk to the appropriate memory, be that main memory for CPU usage or the GPU memory for GPU usage. Before you can do anything in one of these things, you have to initialize your variables. So we created all those variables, but they don't have any data in them whatsoever when you first create the graph. And if you don't put data in them, even though the computer has information there, it will not use it. It will refuse, and it will ask you to put data there. This is the fastest way to do that. It just puts a bunch of random numbers in there, which is good and bad. This example here, I just wanted to show that you can actually take a tensor and you can just evaluate it right in situ for the purposes of debugging or whatever. And in this case, I'm actually doing it on a wholly different machine. I've decided I don't want to do it on this machine. I'm going to shove it off to GPC or AWS or something like that and have it do it for me, right?
Did that one use the old cores in the CPU or the parallelized to the GPUs?
It depends on what you tell it to do. You have to tell it with a device. By default, it will use whatever you have in your configuration file, which is usually your CPU. And you do want to use your GPU if you're doing any kind of heavy lifting. If you're using a lot of data, you want to use your GPU. If you're building a big model, you want to use a GPU. If you're using images, you want to use a GPU.
Most of that is abstracted.
Yeah.
There is some like configuration setup, right?
Yeah.
It's mostly like your code will end up looking the same.
Mm-hmm.
It's just the configuration.
Yeah.
When you run on Markdown, for instance, I was showing what code is using, or you're not using all the codes or no. But if you run R, that's very slow, so it's not using.
So that's actually being determined by the operating system most of the time. When it's using GPU or CPU, which CPU is being used is managed at a lower level, and you often don't have control there. With TensorFlow, you can only tell it either use the CPUs, and then the OS will decide which CPU is being used at what time, or use a specific GPU. And GPUs are built in such a fashion that they always use every core all the time that are on them. Even if there's no data there, those cores will still be executing something. There's just garbage, and you won't use the data. Okay. And let's see. The other important thing I want to point out here, well, two things. When you have placeholders, you have to give it a feed dictionary, and for each variable or for each placeholder, you have to give it a set of data. If you attempt to run X here, which is a placeholder, without giving it data, it'll throw an error because it doesn't know what to do. It has no data to operate on, right? We told it we're going to give it data. Now we must give it data. The last thing to point out is that when you create a session, you must close a session. This is allocating your memory. This is assigning a GPU. If you do this repeatedly, your machine is going to slow down heavily because it's going to be trying to run a bunch of these sessions at the same time. It's like taking an object. Again, it's analogous to objects, right? You have an object definition. You create a million instances of that. It's going to slow down your processes significantly. Yeah, I'll leave it at that. Keras makes all of this easier. You don't have to deal with graphs. You don't have to deal with sessions. It does it for you. It simplifies common operations. Touching on the question earlier, it was a library or is a library that abstracts TensorFlow and Theano, so I can switch back and forth between them very easily. I just go into its configuration file, say use Theano now, and it will. And as long as you haven't done anything specific to one of those libraries, it will work, and it's great. Focusing on simplifies common operations. In this case, I'm going to make a placeholder. I'm going to say this thing's going to have 3 hidden units. I'm going to create a weights matrix. I'm going to create a bias vector. I'm going to perform the pre-activation and then the activation. All of this is necessary to get to the activation. But when you're using Keras, I need these two, define a layer, and there's my activation. Done. Right? It manages the weights, the biases, creating them, optimizing them, the graphs, the sessions, all for you. Another example here is if we go back and look at this, if I want to do more than one layer, which is what deep learning is about, I have to do this again and again and again until I have done all my layers. Whereas with Keras, I can just say, I want a model that's sequential. I'm going to add a dense layer to it. I'm going to add another dense layer to it. I'm done. Right? Very fast. This doesn't allow you to dig in necessarily to the guts. If you want to do something really novel in this model, you're not going to get there. You can go in and you can modify Keras. It's very easy to do. Or you can actually write TensorFlow right in the middle of this thing, and it will respect it. So it'll take, say I've got a model, it's sequential, I have a dense layer, then I activate it, and then I multiply, or I run it through cosine, and then I run it through a dense layer, and then I get the output. It will do that, and it will work, and it'll work as you expect it to work. So you can mix Keras with low-level TensorFlow, and it works very well. And then there's a whole lot of things that I'd love to talk about that there isn't time in this talk for. I taught an entire session on deep learning, and I still didn't get all the things I wanted to talk about, right, when it comes right down to it. The most important one that I'm leaving out is called Tensor Board. This is an application that you run. When you build your model, you augment it with certain TensorFlow calls, and that will save data at certain points. And then Tensor Board will allow you to visualize your model, actually see a graph of what your model looks like, and allow you to visually verify it. And I really should have put in an image to that end. I apologize for not doing that.
The graphs that you showed us of the validation and the training, would those have been created with Tensor Board?
Yes.
Okay.
Yep. And so you'll see that any variable in the system you want to monitor, any learnable parameter, any statistic, you can hook into Tensor Board, and it makes it really easy to see. I highly recommend learning that. Learn TensorFlow, learn the pain of TensorFlow, then learn Tensor Board, and you feel a lot better. It's like going from Python to IPython. Like, woohoo! Lite. TensorFlow Lite is focusing on mobile and embedded applications. These models are big, they take a lot of memory. It's very complicated to boil them down to fit on your phone. But we want that for a lot of reasons. Scopes for variable and resource management. I can actually make a model that will run on multiple CPUs and GPUs across a whole bunch of different nodes in a cluster. You want to use scopes, or you're going to find it's very painful to do that otherwise. And then estimators. Estimators are actually a higher level API than Keras. I can just say, do a logistic regression. Here's the data. Done. Right? You can't do that with Keras. You actually have to define your logistic regression, define your loss function, define your optimization. Someone has already done it, and they call it an estimator. It's one of many estimators. Right? And that's all there is for me. So I appreciate you coming out. A lot of faces. It's really exciting. Yeah. Questions? We had a lot of good inline questions. Any additional ones? All right.
Do you know why the GPU is not supported on the Mac anymore?
I don't. I did not know that was the case.
I do.
Why is that?
Because TensorFlow utilizes CUDA, and Apple.
Oh,
Apple has used AMD GPUs for a really long time, and CUDA is not supported with your AMD GPUs.
So you can get one of these, and it's configured for CUDA out of the box, which is really nice.
That said, I want to re-emphasize with that question that deep learning takes data and compute. Your laptop's almost never going to cut it.
Yeah.
It's true. It will play Atari if you run the ActorCritic algorithm. It will do it, and it will do it really fast. But for most applications, you not really need the laptop anymore.
There are other resources if you want to use like a cloud somewhere for free. Do you know Floyd Hub? So Floyd Hub is something they'll give you, as long as it's public, they give you 10 gigabytes of storage for free. And you can play around with TensorFlow on that. And then,
They'll give you $300 in credit.
yeah, that's the other one I was going to mention. Is
Which
that
one?
talk to Joe and he'll hook you up, or he'll tell you where to get hooked up.
I think $300, that's all I heard all day. Oh, yes, of course. Yeah, in fact, Google Cloud's the one that I generally recommend for my smaller clients. The Google products across the board is really easy to use, really easy to customize, so, you know, use them, they're cheap.
And I'm going to be really quick about this part, because I know everybody wants to go, because we have a raffle, guys. Who does not have a name tag? Quickly. Anybody missing a name tag? Raise your hand. Boom.
Bob, I got you.
Bob, you're 37.
He's 38.
38. Joe's 39. Come on. Work. Yes. Okay. Let's see how quickly I can do this. So what are we at then? Last chance.
38, so 39 in total. We started to see that.
Yeah, it's 39.
Okay, so number of Pythonistas is, I like redundant math people. What are we at, 39?
Yeah.
So including 0, but I'm not going to get included, so. Random. And let's try to make sure that we've got this right here. Okay. Oops. Sorry, I'm also doing the video editing as we do this. Okay.
Also, which desktop environment are you using?
I use i3. Awesome. So first, or whatever, if you win, you get to choose any of these 3 prizes. We got a big sticker, small sticker, and this awesome hands-on machine learning with Scikit Tensorflow. This one just came out. This is actually one of the more expensive books that I've gotten us. Thank you, Tech Systems. Oh, okay, it's not, but thank you, Tech Systems. But yeah, so you want to hit enter for me?
Sure. Who's gonna win? Put your hand up. Nobody. Okay, no.
21. Yeah. You wanted 22 today.
Oh my god, I went 24.
You wanted 24.
Yeah.
I'm glad you got 21.
I have to go for it, yeah.
That's good. Okay, 12. Who's number 12? Yay! Big sticker, small sticker?
Small sticker.
Small sticker.
Thank you.
And for the big sticker, 24.
Oh, I would want either way.
No? 24 left. 6. Yay! All right. Thank you all for coming. The next meetup is, who can tell me right off the bat?
Next month.
Next meetup is the first Wednesday of next month, which is the 5th of December. I will see you there. It will be about testing in scientific computing. So how to test all the stuff that we just learned. We will also probably have like a Python moment where we do like something really fun and easy in 15 minutes. So. Thanks for coming.
Thank you.